Number 25, it's asking you which of the following is a solution to differential equation dy dx equals 2 sine x. Well, they're talking about initial condition of y of pi equals 1. So they're referencing a basic y, so I have to integrate. So I'm going to do y, or excuse me, the integral of 2 sine x dx. Okay, what I'm going to get is negative 2 cosine x plus c, and that's going to be set equal to my y of x if you like, whatever. I'm going to say that, y of pi equals negative 2 cosine of pi plus c. Well, I know y of pi is equal to 1, so I put a 1 here. Negative 2 cosine pi plus c. I know that cosine of pi is negative 1, so I get negative 2 times negative 1. 1 equals 2. Subtract the 2, you get negative 1 equals c. So putting this value back into there, I get negative 2 cosine x minus 1, which should be choice E. For 26, I started doing kind of this fundamental theorem of calculus, where this is just the integral of 0 to x e to the negative t squared dt. Long story short, you're basically saying e to the negative x squared. Okay, if that is your your integral of g prime of x, therefore your g double prime of x is equal to just that. For this one, I basically plugged in x values between 0 and 2 in for this, and I got positive numbers. I mean, think about it. If you plugged in 1, you have e to the negative 1, and that's 1 over 2.7, whatever. That's a positive value. In that case, we know that g is increasing and the graph is concave up, so this is choice A. For number 27, with this notation, they're basically telling you to do the second implicit derivative, differentiation, however you want to refer to it. Do the second one, okay? So if this is what we have here, I'm going to derive using the quotient rule, using implicit differentiation. So the second derivative will be the denominator times the derivative of the numerator minus the derivative of the denominator all over the denominator squared. So what I'm going to do is I am going to substitute this dy dx in for there and for there. So what I've done is substituted this entire fraction in for these dy dx's. So what you can do for yourself is you can kind of, instead of trying to simplify all this and substitute, I'm just going to do it right here. So I'm going to plug in 3 for x and 0 for y right here. So you have 2 times 3 minus 0 all over 3 plus 2 times 0. So we get 6 over 3 and we get 2. So for these two spots, I am going to just replace it with 2. I guess you could have done that right here, but for visualization, I plugged those in. So for all these x's, I'm going to plug in 3, and then for the y's, I'm going to plug in 0. So times 2 minus, I just told you that this was 2, minus 1 plus 2 times 2. 2 times 3 minus 0, all over x, or excuse me, 3 plus 2 times 0 squared. 0 minus 30, all over 9, you get negative 39ths. This reduces to negative 10 over 3, which was choice A. For this one, they want you to find the acceleration when the velocity is first equal to 0. So what I'm going to do here is find the derivative, which is the velocity. This is cosine of t minus, or actually in this case it's going to be minus and negative, so it's plus sine t. The second derivative, which is the acceleration, is going to be negative sine t plus cosine t. So in this case, what I'm going to do is take the velocity and set it equal to 0, because it says when the velocity is first equal to 0, I need to figure out that time. So to solve, I have cosine t equals negative sine t. Or in a converse fashion, you have negative cosine t equals positive sine t. And the first place that happens along your unit circle is in this second quadrant. Remember, the sine is positive here and the cosine is negative. Okay, where are they equal? At 45 degrees, or pi over 4. In the second quadrant, that's 3 pi over 4. So what I have to do is then take that into my acceleration and evaluate 3 pi over 4. Negative sine 3 pi over 4 plus cosine of 3 pi over 4. Negative sine, negative, positive square root over 2. This is negative square root of 2 over 2. I get negative square root of 2 over 2. Those cancel, you get negative square root of 2, which is choice A.